So in this video, we're going to continue on with learning trig identities. Here's a couple of more that are somewhat common in calculus. You should at least be familiar with them, and they're called the double angle identities. For these, I can actually show you pretty easily where they come from. Last video, we talked about the sum and difference identities for both sine and cosine. Here they are. And in order to get a double angle identity, all we do is we just pretend A and B are both the same angle. Let's just call them both theta. So if I plug in sine of theta plus theta, so this is my A, this is my B, and use this top identity, of course, theta plus theta is 2 theta. That's what we mean by a double angle identity. But using the identity, I'm going to get sine of theta cosine of theta plus cosine of theta times sine of theta. And notice, remember, the order of multiplication doesn't matter. So sine theta times cosine theta is exactly the same as cosine of theta times sine theta. So I could just combine these and get an identity for sine of 2 theta is 2 times the sine of 1 theta times the cosine of 1 theta. This is a double angle identity for sine. There's another double angle identity for cosine, which you could find in basically the same way, where you use the identity for cosine of A plus B and just replace both A and B with theta. So it might be good, just pause the video, try that, and see what you get. Okay, if this is A and this is B, I'm going to end up getting cosine of theta times cosine of theta. Remember, for the cosine angle sum difference formula, if I'm using the top number here, if I'm adding, I'm actually subtracting now. So it's minus sine theta times sine theta. Well, cosine theta times cosine theta is cosine squared theta, and this is minus sine squared theta. And of course, theta plus theta is 2 theta. So here's my identity for the double angle identity for cosine. Notice it looks somewhat similar to the Pythagorean identity. That's one way I remember it. The Pythagorean identity, remember, was cosine squared plus sine squared theta equals 1. But if it's cosine squared minus sine squared theta, that's actually equal to the cosine of 2 theta. Okay, these identities, one way you can see them in action here. Here's some problem. Say we have the sine of theta is equal to positive 4/5. And according to all students take calculus, cosine could be positive in either the first or the second quadrant. We'll go ahead and put 1 or 2. But here, they're actually telling us, if you think about theta, it has to be between pi over 2 and pi. Here's pi over 2, here's pi. If theta has to be in here, that means this triangle that we're going to draw has to be in quadrant 2. So let's draw our triangle that represents this in quadrant 2. Sine is opposite over hypotenuse. This is actually theta. And okay, that's just using the given information. Perhaps I should have started with this. If they're asking me for the sine of 2 theta, what they're actually asking for, this angle has a certain degree measure or radian measure. We're actually, imagine that being doubled. So you're probably over in the third, possibly the fourth quadrant. But we're not even going to need to draw whatever angle that is, because to find the sine of twice theta, we can use our identity, which is it's equal to 2 times the sine of theta times the cosine of theta, which means this information we're getting from the given information is all we need to find the sine of 2 theta, even though it's not the same angle, it's double that. Okay, sine of theta we know is 4/5, so that's 2 times 4/5. And I can easily find the cosine of theta by figuring out this missing side. Let's call it x. By the Pythagorean theorem, x squared plus 4 squared equals 5 squared. That's 16 That gives me x squared equals 9. So x would be plus or minus 3. And in this case, since it's going to the left, it's actually going to be negative 3. And the cosine of theta would be adjacent over hypotenuse, negative 3/5. And if I multiply this all out, you can just go straight across. 2 times 4 times negative 3 gives me negative 24. The denominator is 25. Sine of 2 theta is negative 24 over 25. The cosine of 2 theta, our identity for that is cosine squared theta minus sine squared theta. We've got everything we need here. We can use this triangle. Again, the cosine is negative 3/5. I'll square that minus the sine, 4/5 squared. That gives me 9/25 minus 16/25, or negative 7/25. It's the cosine of 2 theta. Sometimes you'll get asked for the tangent of 2 theta, and I never showed you a double angle identity for tangent of 2 theta, but we don't really need one. Some books will actually derive a formula for tangent of 2 theta, but I feel like it's useless. Well, not useless, but you don't really need to do that, because we know the tangent of 2 theta should be the same as the sine of 2 theta over the cosine of 2 theta, and we already have worked those out in our previous answers. So we can just say this is negative 24/25 divided by negative 7/25, or negative 24/25 times the reciprocal, 25, and this is 7. 25s cancel out, 2 negatives cancel out, and we get 24/7 as our answer for tangent of 2 theta. So those are the double angle identities.